Hello guys, I'm back. My name is Jeferson Costa and I teach students, graduates and engineers how to work with chemical process engineering and plant design. And today I am here with you to share a PNID sheet and ask you what of the arrangement would you choose if I asked you what is the correct one. To work with chemical process engineering plant design, you must deal with heat and material balance, most often using process simulation softwares as Aspen HiCs, Aspen Plus, Unison Design, and etc. You need to deal with engineering drawings, process engineering drawings, mainly pipe instrumentation diagram and also process flow diagrams. And here you can see a sheet for a pipe instrumentation diagram and also with process data sheets at a minimum. And process data sheet is the document that has the results of your heat and material balance to purchase or to forward for other discipline to the specification, and after that purchase the equipment, control valves, pressure relief devices, instrumentation, and etc. So one of the tasks of a chemical process engineer in plant design is to deal with engineering drawings, and the main engineering drawing in a plant design is the piping and instrumentation diagram, and you can see an example just in front of you. Now imagine that you are with an interviewer and the interviewer show this sheet for you and ask to you what is the correct arrangement considering these two arrangements shown in the PNID sheet. Which one of them would you choose? So let's start with understanding what is this process. In this process we have a blower that is responsible to taking a gas, a saturated gas, build pressure on it and deliver for another process. What is important here to understand is that it is a saturated gas, so depending on the weather it can condensate liquids, and it is a gas, it is a blower, it's not a compressor. A blower is a rotating equipment where the delta P between the inlet and the outlet is much lower than a compressor. This is a summary for a comparison between blowers and compressors. So here what we have an isolation valve, we have a joint expansion, we have the rotating equipment, a joint expansion in the discharge of the equipment, a check valve, and also an isolation valve. Below the SP205, we have the SP204. That is basically the same arrangement, the same components. There is the same components for this arrangement. We have a joint expansion or an expansion joint. We have isolation valve, another isolation valve, the expansion joint, and the check valve. So to answer this question, let's verify what happens if there is any kind of plug in the check valve. If my check valve needs maintenance and I am using the arrangement below, I will need to, considering that these two equipments is running in parallel or not in parallel in this case, let's suppose that I operating with SP204 and I identify that my pressure downstream of the process is too low, and when the maintenance team goes to the field, they verify that there is a malfunctioning of the check valve. In this case, to do the repair of the equipment of the system, we need to remove the internals of the check valve, do the maintenance, and return to operations. As the check valve is installed in this arrangement, we are not able to keep with the production because I am not able to isolate the check valve from the downstream process. If we compare to the above arrangement, if my check valve has some kind of issue, I can isolate the system, the discharge of the system, and of course that I will stop my machine and isolate also the inlet of the machine. But in this case, if I need to keep producing, I can just isolate the discharge and start the SP204 if they are not running in parallel. If they are running in parallel, I just need to stop the SP205 and keep with the 204. So in terms of installation of the check valve, it's always better to have an isolation valve between your check valve and your process in a way that you are able to do the maintenance in the check valve without stopping the production, or at least not interfering in the production. So the first point for this schematic is that the check valve in this arrangement is not in the best position because it should be upstream of the isolation valve. And of course that you need to verify what is upstream and what is downstream in an arrangement. In this case, my fluid is going from the left to the right. So this is very important to you verify in your pipe instrumentation diagram. Another thing to observe here is that we are talking about rotating equipment, and because of the nature of this equipment, we can have vibration. Small vibration is allowed. It's not an issue for the equipment, but this vibration connected with the pipes can lead to a higher vibration and some kind of resonance in the system. So you don't want to have that, and moreover, you don't want to have external force in the nozzle of your equipment. So because of that, the best position for the installation of the expansion joints is in the flanges of your equipment. So you will have the inlet nozzle and the expansion joint, and you will have the discharge nozzle and the expansion joint. So because this way you guarantee that any kind of force is not transmitted from the pipeline downstream of the discharge of the equipment or upstream of the equipment, because any vibration in the arrangement will be absorbed by the expansion joint. So there are 2 points for the arrangement above and any points to the arrangement below. Another thing to observe here, as I mentioned to you, the gas is saturated, and when we stop both machines for maintenance, eventually we can have condensate inside the machine. So in the bottom of the blower, we will have a drain valve, and in both cases they have the same arrangement. Before starting the equipment again, especially if we are talking about too many days of maintenance or without operating the machine, or if the weather is very cold, before starting the equipment, you must open the drain valve to make sure that there is any kind of liquid inside the rotating equipment, because the blower is supposed to, or is designed to, compress gas or vapors and not to compress liquid. Based on this, next time that you get a pipe instrumentation diagram for verification, or you need to develop a new piping instrumentation diagram, take a look, observe these details, because it seems to be details, but for maintenance and operations of the plant, it's very important. Make sure that the isolation valve of your equipment will allow you to interfere, has a less level of interference in your operations. So guys, if you like this video, share it with other chemical process engineers and in other groups, because this way you can help me to achieve 100,000 chemical process engineers around the world. So this is it. I hope you like it, and I'll see you soon in the next video. Bye bye.